Okay, this is the next question that we have on the menu today, and it's asking us how do we find the exact value of arctan or inverse tan of root 3. So tan negative 1 of root 3, or inverse tan, it's arctan. Let's just say that this is equal to theta, because we know that if we take the tan of both sides, the inverse of this is going to be 3 is equal to tan theta. And we know that tan theta from our SOHCAHTOA has to be opposite over adjacent. Op over adjacent. Okay, so essentially, if we have a right angle triangle like this, let's call this op adjacent, that's theta. We know that op over adjacent is equal to root 3. And if we have adjacent equal to well, pretty much we have this relationship, and if we set one of the numbers, like, you know, because we can scale triangles to be similar triangles, and they're going to have the same angles. Let's say if we say adjacent is equal to 1, that means equal to 1, that means that would imply that opposite is equal to root 3. Okay, so given this, there's not really a great easy way to calculate this. Like if we were to draw this out like this, and we know that this is 1 and this is like root 3, we'd pretty much be looking for the angle like that. Now, which angles do we know correspond to having having this? Oh, I see. Right. So, you see, imagine how let's try to find the hypotenuse here. And we know that we can find the hypotenuse fairly easily, because we know that the hypotenuse is going to be the square root of 1 squared plus root 3 squared, which is going to be 1 plus 3. And that means the hypotenuse has to be 2. And if the hypotenuse is equal to 2, and this is the right angle right here, this would mean, like, if we were to clone this, and we know that the angle here is 1, or I mean the side length here is 1, we could clone this triangle. Oops. Clone a reflected version. Like this. So this is 1, this is 2. And this is 2, and this is 1. Like that. All of a sudden, we have to have an equilateral triangle. Be an equilateral triangle. Because, well, this entire side length is going to be 1 plus 1, that's 2. All the side lengths are the same. So the only angle that we can have in an equilateral triangle is 60 degrees, or pi over 3. So theta equals 60 degrees, or pi over 3. Okay, so I guess thinking back to some actual geometry diagrams can definitely be helpful in thinking about this, right? So I think, yeah, we used our knowledge of equilateral triangles and their properties. We used Pythagoras theorem to find the hypotenuse, And also use SOHCAHTOA to recognize that these are going to be the arrangements of our angles. Okay, so this is all super duper cool. Super duper cool. So we know that theta has to be 60 degrees through this process. You could also just ask your calculator, and that would probably be a lot easier, but you know, if you're not allowed to use your calculator and you have that type of test going on, well, this could definitely be another great way to address this type of question. Okay, so the above solution is good. Could be found with some graphical geometric analysis. Answer appears to come from direct mathematic evaluation